This stoichiometry problem involves being given a target amount of product and calculating how much reactant you need to get to that product. So again, we set up an IRF table, although it'll be a little bit different this time. We start with our reaction. So we have our two reactants and we have the product formed. We're going to make sure that that reaction, that chemical equation, is balanced before we continue. And now the information that we're given to fill in our IRF table is not an amount of reactant, but rather a target amount of product. So we're given a target amount of product in kilograms. In order to plug this information into the IRF table, we must convert it to moles. So the target mass of product in kilograms is converted to moles using the molar mass of the product in question. Once we have the number of moles of product that we are aiming for or trying to achieve, that amount of moles goes into the final line on our IRF table because it's the final amount of moles that we would like to get of product. So we move that amount down into the final moles of product. That tells us how many moles of product reacted. So we can fill in the R line in our IRF table above that for our product. This is because we know that we start with zero product. Starting with zero product, knowing the final amount of product, we can fill in the R line. This allows us to go backwards. If we know how many moles of product were formed, we know how many moles of each reactant were required. At this stage, we're paying attention to the stoichiometry. We need 2 moles of sodium for every mole of product and 1 mole of oxygen for every mole of product. So now, if we presume that neither reactant is in excess in this particular problem, we can calculate how many moles of each reactant are needed. Now, in the question, you are actually asked for what mass of each reactant to use in order to get a target mass of product. So the final stage in this problem will be to convert the moles of each reactant into masses. And so we'll proceed to do that for sodium and for oxygen. Remember that the oxygen molar mass is equal to 2 times the molar mass of an oxygen atom, whereas the sodium molar mass is equal to 1 times the molar mass of sodium atoms. The stoichiometry of the equation is no longer relevant for this part of the problem. So we calculate the mass of each reactant, and once the masses are given, then we have our final answer. Note that we could give the masses either in grams or in kilograms because the question has not specified the final units. It's only specified that a mass is required. Notice also that we have 3 significant figures in each answer, just as we do in the initial bit of information.